The point C need not be inside the set A. Okay. So how will you find out the limit points here? Okay. So the set now is this 1, 2, 3. Okay. Only these points are there inside the set. Okay. So whether 3 is a limit point of this set. It will be a limit point if every open interval centered at C contains at least one point of A different from C. Okay. What is A? A is the set 1, 2. Okay. You take any open interval centered at 3. Okay. So this one. This open interval. It does not contain any points of A other than C. Only C is there. Okay. Because there is a lot of gap between 2 and 3. Connect gap as well. Okay. So if it is a limit point, every open interval centered at this point should contain at least one point of A. Okay. Other than C. So this is not happening. If I take this open interval, then it contains the point 2. But if only one interval satisfies, we cannot conclude anything. Okay. Every open interval centered at C should satisfy that condition. Okay. But here you see from the diagram itself it's clear. If I take this open interval, okay, say 2.5 to 3.5. Okay. If I take this open interval, that is what is our delta here? Delta. What is delta I have taken? Delta is 0.5. Okay. If I take delta to be 0.5, then the open interval 3 minus delta to 3 plus delta. This does not contain any point of capital A other than 3. Okay. It contains the point 3, but I need some other point. No point line. Okay. Right. So this 3 is not a limit point. Whether 2 is a limit point or not, 2 is also not a limit point. You take this type of open interval, it contains only the point 2, not any other point. Okay. 1 is also not a limit point. If you take this type of open interval, it contains only the point 1, not any other point. Okay. So 1, 2 and 3, they are not limit points of this set. Okay. Aro no kuno limit point as any centered by it, or here somewhere here can we have a limit point? We will not have any limit point. Because suppose you take one point here and you can construct an open interval of this type, it will not contain any other point. Okay. Right? In particular, if I take a point say x or x0 inside A complement, okay, that is R difference A, and I measure the distance x0 minus 1, x0 minus 2. Okay, and x0 minus 3. Okay. Suppose I take a point in the complement, okay, and I want to check whether this is a limit point or not. Okay. What I will do, I will measure the distance between x0 and 1. Okay. Measure the distance between x0 and 2. Okay, and measure the distance between x0 and 3. Which one will be largest out of this? Which one will be largest or which one will be smallest? Kunta largest. So you have to analyze. That is why the name of this method is real analysis. Theory of real functions. If I take a point outside, the set is only 1, 2, 3. Okay. If I take a point outside, where will that point lie? कौन जगह था? Where will the point lie? कौन जगह है? तो एकदम सिंपल. हाँ? दिखा ना आपको नहीं? This is one possibility. एकटा possibility. This point may lie here. Okay. Somebody else may take a point which lies here. Huh? Somebody else may take a point which lies here. Somebody may take a point which lies here. Okay. So there are lots of possibilities. It's not necessary that the point will be very far from 3. Okay, it's not necessary that the point is very close to 3. Okay, so we cannot say which one will be the largest. We cannot say. It depends on the point we choose. Okay, if I choose the point here, then distance between x0 and 1 will be largest. Okay, if I choose the point here, then distance between x0 and 1 will be the smallest. It depends. Okay, so whatever it is, once we take a point outside, we can compute this. এই তিনটা আমরা compute করতে পারি. Okay, suppose I have taken this point. Suppose I have taken this point. Okay, so what is the distance between x0 and 1? This distance. If I construct an open interval of radius this, okay, then I will always get a point which is inside A. 2 and 3, they are points inside A. So that is not working for me. Okay, if I take a open interval of this type, distance between x0 and 2, okay, and construct, then also the point 3 is inside. No? But if I take an open interval of radius this much, x0 minus 3, this distance, and half of that, in that case, that particular open interval will not contain any point 1, 2, 3 of A. Okay, so what should I take as delta? Once I know this distance, what should be delta? What should be delta? If the point x0 is somewhere here, what should be delta? Here the delta that I had taken was half of mod of x0 minus 3. If x0 lies here, what should be our delta? I should take a delta of this type. This delta, for this delta, the open interval will not have any point of A. Okay. So what will be delta in this case? Half of x0 minus 1. Okay. Distance between x0 and 1. So in general, what should be delta? So idea for a just what should be delta in general? Which distance should I take out of all this? Which distance should I take? Half of which distance should I take? About x0 minus 1. See, in this case, I have taken the distance half of x0 minus 3. In this case, I have taken the distance half of x0 minus 1. Suppose x0 lies somewhere here, very close to 2. In that case, I will take my delta to be half of x0 minus 2. So, what should I take out of all this 3? Otherwise, you cannot understand the concept. See, x0 is a point outside this set. ওটাই তো আমি অ্যানালাইজ করার চেষ্টা করব whether this will be a limit point or not. Okay, you start with a point outside this set, okay, and you compute this distance x0 minus 1, x0 minus 2, x0 minus 3. You have these 3 distances. Okay, suppose this is 1 centimeter, this is say 0.5 centimeter, and this is say 0.9 centimeter. Okay, so if I construct an open interval having radius 1 centimeter, in that case the points 2 and 3 they will be included inside the open interval, because the open interval it is of this distance, x0 is at the center, x0 minus 1, this is the largest distance, so 2 and 3 will be included there. Okay, if I construct an open interval of radius 0.9, in that case the point 2 will be included. Okay, but if I construct an open interval having radius half of the smallest one, okay, in that case everything will be outside. So what should be this delta? Out of all this 3 distance, what should be delta? You have 3 different distances. Which one did I select? Which one should I select? So that the open interval does not contain any other point. Which one should I select? One is here, two is here, three is here. Okay. Suppose x naught is here. So which radius will give me an open interval which does not contain any other point? Huh? X naught minus 3. This is the distance. X naught minus 2 is a larger distance. Okay. X naught minus 2 is a larger distance. If I take x naught minus 2, this point 3 will be included. So I cannot conclude anything. Okay. So, and if I take x naught minus 1 as the radius, x naught minus 1 is this distance. If I take this radius, then 2 and 3 both are included. So we cannot come to any conclusion. Okay. But if I take x naught minus 3, this distance, is it? A distance, and then consider the half. In that case, the open interval will be this. Okay. X naught minus, x naught is this. So x naught minus this. Open interval will be this one. This will not contain any other point. Okay. So out of all three possibilities, which one should I select? X1 minus. In this case, it is x0 minus 3. In this case, what will be this? If x0 is here, x0 minus 1. Okay. In this case, so try to observe which one I am selected. Jeta samne ache. That means what? Out of all these distances, which distance I am selecting? এইটা আমি সিলেক্ট করলাম না, এইটাও সিলেক্ট করছি না, আমি সিলেক্ট করছি এইটা, smallest minimum. Okay. If I take delta to be half of minimum of all this, okay, in that case whatever open square I draw, this will never contain the other ones. Okay. That is the thing. I have to take delta to be half of minimum of all this distance. I don't know what are this distance. Okay. But I know if I take this delta to be minimum of all this, mod of x naught minus 1, mod of x naught minus 2, mod of x naught minus 3. Okay. If I take delta to be half of minimum of all this, okay, then every time whatever open square I draw, it will never contain this particular point. Okay. Clear? This is the thing. Because this distance will be always, this distance is always less than x naught minus 1. This distance is always less than x naught minus 2. Okay, like that. That means what? If I take a point outside this set, then I can construct an open sphere or open interval which does not contain any other point of it. Okay, that means what? This point cannot be a limit point of the set. Okay, this point cannot be a limit point. Okay, if it is a limit point, then every open interval should contain some point inside it. Okay, so if it is not a limit point, that means what? There exists an open interval which does not contain any other point. Okay, this is the meaning. So this point has no limit points. This set has no limit points. It has no limit point. Okay. So in general, a finite set does not have any limit. Yeah, we have already shown. If I take a point, 1, 2, 3 are not limit points. If I take a point outside A, then I can choose the radius to be delta to be half of this. Okay. Then the open sphere with center x naught and radius delta will not contain any other point. Okay. So this x naught is not a limit point of the set. So any point outside this set is not a limit point. Okay. That means the set has no limit points. Okay. So this was actually of second semester. Unfortunately, I could not cover this. That's why you are finding it difficult. Okay. So don't worry. এই সেমিস্টারে অ্যাকচুয়ালি এতগুলো লিমিট পয়েন্টস এর কনসেপ্ট লাগতো না, জাস্ট উই নিড টু আন্ডারস্ট্যান্ড হোয়াট ইজ এ লিমিট পয়েন্ট। ওকে, উই উইল বিগিন উইথ দিস, সো উই ডোন্ট নিড টু প্রুভ ইট নাও। এটা সেকেন্ড সেমিস্টারে দিয়ে আসছে। আর নেক্সট টাইম অফ ফিফথ সেমিস্টার টপোলজি Okay. So don't worry. So some other examples. Send more examples. One, say, for a equal to closed interval or open interval 0, 1. Okay. The endpoints, I think 0 and 1 are limit points. Also, every point inside a the limit point. So this is one example. Another example is, say, number 2. For a equal to closed interval 0, 1. Every point in A is a limit point. Okay. Here for this closed interval, every point is a limit inside. Okay. So these are some examples. So let us go to the definition of limit. Limit of a function. Limit of a function. Limit of a function. That A be a subset of R. Okay. So we are considering only real functions. Okay. Functions defined on subsets of R and having real value. Let A be a subset of R and C be a limit point. Be a limit point. Limit point of. Okay. Let A be a subset of R and C be a limit point of. Real number L is seen to be functions are dependent on number. Let A subset of R, C be a limit point of A. Also let F be a function from A to R. Okay, let F be a function. Just write this part. Let F from A to R be a function. Let F from A to R be a function. F from A to R be a function. Then a real number L is said to be a limit of F at C if so the last day I told you if the distance between fx and L can be made as small as possible by reducing the difference between x and c. Okay, that is the concept of limit. So last day kuchlam nahi. In the first semester also probably I told you. What is the concept of limit? The distance between fx and L can be made as small as possible. As small as possible means it can be made less than any arbitrary positive quantity. Okay. By what? By reducing the difference between x and c. Okay, so this is the concept of limit. Okay, so if you see the diagram, suppose what is limit x tends to 2 of x square? What is that? This is equal to higher secondary concept. What is that? What is that? Limit x tends to 2 of x square. What is that? 4. Okay. So how will you understand in diagram? Suppose x square is this parabola. So x equal to 2 is suppose this point, and f of this limit is 4. Okay, so this point is 4. So it's 2, 4. Okay. If you approach x, if you approach 2 from this side, okay. Suppose you are at this position x. So what is the difference between fx and L? This is the difference, no? Difference between fx and the limit is this. Okay. And what is the difference between x and 2? This one. Okay. If I want to reduce this difference, what I will do? I will come closer to 2. No? I will approach 2. Okay. So now what is the difference between fx and L? Is it? See, now the difference between fx and L is decreasing. Okay. I am approaching x towards from the left side. Okay. Suppose I want to reduce the difference further. Then what I will do? I will come further close to x, further close to 2. Okay, I will closer. So now what is the difference between fx and L? This is the difference. See. So difference between fx and L is decreasing. How it is decreasing? By decreasing the difference between x and 2. Okay. So that is the meaning. The function f has limit L at c if the difference between fx and L can be made smaller by reducing the difference between x and c. Okay. If I approach from this side, this side to be approach from, you see x is here. So what is the difference between fx and L? This much difference. Okay. If x is here, if you come closer to x, closer to 2, see what is the difference? This is the difference between fx and L now. Okay. So if I come closer to x from the right side, okay, then also this difference is decreasing. So difference between fx and L is decreasing as we approach x 2 from the right side. Okay. As we approach from the left side also, this difference is decreasing. Okay. So if this happens, then the limit of f at x equal to 2 exists. Okay. Otherwise it doesn't exist. Diagram. As I approach 2 from the left side as well as from the right side, the distance between fx and L keeps on decreasing. Okay. And if the limit does not exist, then this distance may not decrease. Okay. For example, just I will give you another example. Oh, this one. If you have this function fx equal to say x plus 1 if x is greater than or equal to 1, and fx equal to x if x is less than 1. Okay. What is the limit? What is the limit at x equal to 1? At x equal to 1, what is the limit of this function? At x equal to 1, what is the limit? Limit x tends to 1 at x. What is that? This limit does not exist. Higher secondary shop What is the writing limit? Writing limit here? When x tends to 1 plus, what is is the right hand limit? 2. What is the left hand limit? 1. So this limit does not exist. Left hand limit and right hand limit are unequal. Okay. This limit does not exist. Okay. Now let us see the diagram. Diagram of the Okay. So fx equal to x plus 1 if x is greater than or equal to 1, and fx equal to x if x is less than 1. Okay. So this will be the graph. This is the graph. Okay. X plus 1. Okay. This will be the graph of the function. Okay. These two are parallel. This line and this line, they are parallel. Okay. This is the line x plus 1. This is the line x. Ita muchunni. Y equal to x is this line. Up to what? Up to x less than 1. Okay. And y equal to x plus 1 is this line. Okay. Starting from x equal to 1. Okay. So see, what is the left hand limit? Left hand limit is 1. So if I approach 1 from the left side, the distance between fx and 1, it keeps on decreasing. Okay. This is okay. If the right hand limit is 2, so distance between fx and 2 keeps on decreasing. At this point also, distance between fx and 2, this keeps on decreasing. Okay. So right hand limit is 2. There is no problem. Left hand limit is 1. Okay. There is also no problem. But I cannot say that 1 is also the common limit. Okay. I cannot say because what is the distance between fx and 1? See, it does not decrease. Even if you come to this point, the distance is very large. Even if you come to this point, the distance is very large. So I cannot say the common limit is 1. I cannot say that. Okay. I also cannot say that common limit is 2 because if you consider this side, the distance between fx and 2 is very large. Even if you come very close to x equal to 1 from the left side, then also the distance is very large. This distance is, we cannot decrease it further. R decrease for us. Okay. So that's why this limit does not exist. Okay. We cannot agree at a common value from left side and right side. Okay. So from left side and right side, the values are different. Okay. So this limit does not exist. Okay. So that is the concept. F will have limit L at C if what happens, if for every epsilon greater than 0, there exists a delta greater than 0 such that mod of fx minus L is less than epsilon whenever or for all x is a with 0 less than mod of x minus a less than mod of x minus c minus c. Okay. This is the definition. For every epsilon, there is a delta greater than 0 such that this distance can be made smaller than epsilon. Okay. इधर मानने वाला क्या? This distance can be made as small as possible. Okay. If somebody says make it smaller than 0.00001, I can make it. Okay. Somebody says make it smaller than 10 to the power minus 1 million. Okay. Then also we can make it. Okay. If that can be done, then the limit exists. Okay. Otherwise it doesn't exist. Okay. So for every epsilon greater than 0, there is a delta greater than 0 such that this distance is less than this whenever this distance is less than delta. Okay. So it's important to write 0 less than mod of x minus c. Okay, because there may be functions where this condition is satisfied for every point which are satisfying this, but for x equal to c it cannot be satisfied. Okay. So that's okay. So whenever, so this means that, let us write. So literally this means distance between fx and L, okay, and L can be made as small as possible, okay, as small as possible, okay. Distance between fx and L can be made as small as possible by reducing the distance between x and c, okay. This is the meaning. Distance between fx and L can be made as small as possible by reducing the distance between x and c, okay. That is the meaning of the intuition behind it, okay. An idea behind it, okay. The distance between fx and L can be made as small as possible, okay, by reducing the distance between x and c, right. So this is for your understanding, right. This is the definition, the critical definition. As small as possible means this distance can be made smaller than any arbitrary positive quantity, okay. Right. Clearly. So it's very important to understand this definition. A definition of the real number L is said to be, so this for existence of limit, this point C need not be inside the domain. We domain now, okay. The point C may not be inside the domain, okay. That means the function may not be defined at that particular point, okay. Even then the limit may exist, okay. For example, in your higher secondary you have done this limit. Limit x tends to c sin x by x. What was that? This limit is 1, but the function is not defined at x equal to c. Okay, so it may happen. So this point C may not be inside the set A. Okay. The point C may not be inside the set A. But the point C has to be a limit point of. Okay. So now you understand why I require this to be a limit point, because if it is a limit point, then every interval of this type will contain at least one point inside it. Okay. Right? Every interval of this type will contain at least one point inside it. Okay. So that is why we require it to be a limit point. Okay. So let us try to see some applications or problems related to this. Okay. They show that before that, let us just prove the existence of uniqueness. Let us show the uniqueness of So this we will write it as a theorem. Let A subset of R and C be a limit point. Limit point of be a function from to R. Then limit of f at C is unique. unique. Okay. So that means there can exist only one L which satisfies that condition. Okay. The limit of limit of f at C is unique. Okay. So a function, the same function cannot take two different limits. Okay. Duta alada limit in the bottom. Okay. It will take only one limit. So this is what we will try to prove. Okay. Uniqueness of limit. Let f a be a subset of R and C be a limit point of A, and let f be a function from A to R. Okay. Then limit of f at C is unique. Okay. Only one limit it can take. Okay. So how we will do this? So first we will suppose that it takes two different limits. Okay. And then we will arrive at a contradiction. Okay. Right. So suppose that L1 and L2 are two limits of f at C. Okay. Suppose that L1 and L2 are two limits of f at C. Okay. Yeah. L1 and L2 are two limits. Okay, limits of the function. We are trying to show that a function will have only one limit. Okay. So suppose that L1 and L2 are two different limits. Okay, we will ultimately show that L1 and L2 have to be equal. Okay, L1 equal to L2. Okay. So suppose that L1 and L2 are two limits of f at C. So if L1 is not equal to L2, if L1 is not equal to L2, then L1 minus L2 is what? If L1 is not equal to L2, then L1 minus L2 is what? What is L1 minus L2? Not equal to what? Not equal to non-zero. L1 and L2 are different. Okay, so L1 minus L2 has to be non-zero. Okay, it's not equal to 0, right? So what can we do? So let that is L1 minus L2 is non-zero. That is mod of L1 minus L2. So what can you say about mod of L1 minus L2? If L1 minus L2 is non-zero, what is mod of L1 minus L2? Mod of L1 minus L2 कितना होगा? Greater than 0, strictly greater than 0. Okay. If L1 minus L2 is non-zero, then modulus of that will be positive, greater than 0. Right? So our definition of limit says that the difference between fx and L can be made smaller than any positive quantity. Okay. So this is also a positive quantity. It also is a positive quantity. So as per the definition of limit, the difference between fx and L1 can be made smaller than this. No? We can make it smaller than this, right? And again, as per the definition of limit, the difference between fx and L2 can also be made smaller than this. Okay. So mod of fx minus L1 can be made smaller than this quantity. Mod of fx minus L2 can also be made smaller than this quantity. Okay. Right. The definition of limit says that we can make it smaller than mod of fx minus L can be made smaller than any positive quantity. Okay. So this is also a positive quantity. We can also make it smaller than this. Okay. So this is the thing you need to understand. So let us take this one as epsilon. Okay. We will make changes wherever required. Okay. So let epsilon equals mod of L1 minus L2. Okay. So So later you may require to change it little bit. Okay, because this particular limit, definition of limit says that the difference can be made smaller than any positive quantity. Okay, so for the time being, let us start with this equal to epsilon. Okay, after that you will see we need to make some changes. Okay, let epsilon equal to this, then since L1 and L2 are limits of f and c, so for this epsilon there exists, see, so L1 is a limit of f, so for this epsilon there exists what? There exists some delta 1, okay, delta 1 greater than 0, and L2 is limit of f at c, so for this epsilon there will exist a delta 2 greater than 0. So for L1 there exists a delta 1, okay, for L2 there exists a delta 2 which satisfies certain condition such that mod of fx minus L1, this is less than epsilon for all x in A with 0 less than mod of x minus c less than delta 1. Okay, clear? Mod of fx minus L1 is less than epsilon for all x in A with or satisfying 0 less than mod of x minus c less than delta 1. Okay, so just I will apply the definition. আজকে বাসা দিয়ে এগুলো আবার পড়িও না, এটা কিছু বুঝতে হবে। শুনুন, এই কনসেপ্টটা বুঝানি হলে বহুত কষ্ট। ওকে, বুঝাও কষ্ট, বুঝানিও। ক্লিয়ার? Just apply the definition of limit. L1 is a limit of f at c. That means what? Mod of fx minus L1 can be made smaller than epsilon by reducing the difference between x and c. Okay, so this is what we have done. For epsilon, there exists a delta 1 which satisfies this. Okay, L2 is limit of f at c. That means for this epsilon, there exists a delta 2 which satisfies this. Okay, so we'll write n mod of fx minus L2. This is less than epsilon for all x in A with 0 less than mod of x minus c less than delta 2. Okay, less than delta 2. Clear? Picture it up. Okay, try to read this again from that first line. What we have done, we have supposed that L1 and L2 are two limits of f at c. Okay, and then we have assumed that suppose L1 is not equal to L2. Okay, then L1 minus L2 is non-zero. That means this quantity, modulus of L1 minus L2 is greater than 0. Okay, and the definition of limit says that the distance between fx and L1 can be made smaller than any positive quantity. Okay, so we can make it smaller than this positive quantity also. Okay, how? So we have taken epsilon as this. So since L1 is a limit of f at c, so for this epsilon there exists a delta 1 which satisfies this condition. Okay, this condition comes from the definition of limit. Mod of fx minus L less than epsilon for all x with 0 less than mod of x minus c less than delta 1. Okay, with 0 less than x minus with one is satisfying. This is not satisfied for every x. Okay, it is not satisfied for every x in A. It is satisfied for all those x in A which satisfy this. Okay, the distance between x and c should be smaller than delta. Only then this will be satisfied. There is the meaning.
And x and the difference between x and x minus c theta. 0 to delta theta.
This should be less than delta 1. So what it is satisfied? Okay, there is the meaning. Mod of distance between fx and L can be made smaller than epsilon by making the distance between x and c less than delta. With delta dependent on epsilon. Okay, epsilon is 1, delta may be something like 0.5 or it depends on the problem. Okay, so So this delta is actually dependent on epsilon. Okay. This difference can be made smaller than epsilon by considering all those x whose difference from c is smaller than delta 1. Okay. प्रत्येकटा x एल लगे satisfy होतो ना. It is not satisfied for every x in. Okay. There are so many x in it. It is satisfied only for those x which satisfy this. Okay. And writing this part is very much necessary with or satisfying. Okay. Satisfying. So this quantity is less than epsilon for every x in A which satisfy this condition. Okay. Right. So I cannot write for every x in A. If I write that, it is incorrect. Okay. There may be many x inside A which does not satisfy this. Okay. In diagram also we have seen. In diagram also we have seen this one. Suppose I want to make this difference smaller than this. Okay. So which values of x will satisfy this? Only these values of x will satisfy. Okay. Because for this value only the difference is less than this. Na? If I take x here, this x will not satisfy. Na? This for this x the difference is larger. Na? Okay. So